Welcome to Physical Science, Unit 2, Section 2, Bohr's Model. So, we're going to be talking about the planetary model. And no, Bohr's model is not boring. It's like drawing. It's like art class. So let's get into the planetary model. Now, the reason why they call this the planetary model is because you'll see that it looks like planets orbiting around the sun. So let's look at Bohr's model. Now, Bohr model diagrams. Write that in, and we are going to be drawing out what a Bohr model looks like. Okay, so let's start off with the center. We're going to represent the center, or the nucleus, where there are protons and neutrons, with a circle. And then we're going to surround it by orbitals. So the first orbit, just like in planets, in the first orbit, it's kind of like a school bus seat. There's only enough room for 2 kids, and if you try to shove a third one in there, it's no good. So in the first orbit, where all the electrons are floating around in this whole cloud, in the first orbit, there's a maximum number of 2 that can fit in there. Can you have 1 kid sitting in the seat? Yes. Can you have 2? Yes, but you can't have more than 2. You run out of space. Then your next orbit, the second orbital, is slightly larger, and now you can take up to 8 kids in this seat. Can you have 6? Yeah. Can you have 4? Yeah. But can you fit more than 8? Nope, you're out of room. So that's kind of the concept behind this. And then on your third orbital, the maximum number that you can have is 18. And your fourth, the maximum number that you can have is 32. So this is going to be your max number of electrons. So if you will please draw in a table of just 2 columns and write energy level and max number electrons. So in your first energy level, a max number of 2. In your second energy level, a max number of 8. In your third, a max number of 18. And in your fourth, a max number of 32. So again, as the orbitals get bigger, you can fit more and more, but these are your max numbers. So our first example that we're going to go over is lithium. So write lithium number 7. So if I look up on the periodic table and I find what lithium looks like, I see that the atomic, or the symbol for lithium is Li. I see in the upper right-hand corner, the atomic number is 3. And then below it, I see 6.941, which is my atomic mass. So write atomic number 3. Again, where is that coming from? Right there. Our mass number, or our atomic mass, is that, which is 6.941. And from this, we can figure out how many protons, electrons, and neutrons there are. So if you recall back ape man, so A-P-E-M-A-N, ape man. So the atomic number represents the protons and the electrons. And then your mass minus your atomic number is your number of neutrons. So let's look at our protons. Protons is an ape, which is our atomic number. So our number of protons, or positive charges, is going to be 3. Why? Because our atomic number is 3. Our number of electrons, or negatives, again, ape man, is 3. Why? Because of our atomic number. Our number of neutrons, though, mass minus your atomic number gives you your number of neutrons. So my mass is 6.941, which I'm going to round to 7, minus my atomic number, which is 3. So that gives me a total number of neutrons, which have no charge, which are neutral, as 4. So once I know this information, I can do a Bohr model. Now, the Bohr model tells you how many protons and neutrons are in the center, and then puts the electrons in the appropriate orbital around the outside. So I look over here and I see my number of protons is 3. So there are going to be 3 protons in the nucleus. The number of neutrons we calculated was 4, so they're going to be 4 in the nucleus. Because remember, the nucleus makes up the mass of the atom. So if you have 4 plus 3, you end up with roughly 7. Now remember, this is an average, which is why it's not 7 on the dot. So then we go back and we try to figure out where our electrons are. So we have 3 electrons, and we have to remember our rules. Well, in my first orbital, it said my max number of kids I can fit in there, or electrons, on this seat is 2. So I'm going to fill it in. 1 and 2. Now, can I fit any more in that particular area? No. So I have to move up to the next seat, or the next shell, because I have 3 and I've only used 2. So I need 3 electrons. Then the third electron would be out here. Now notice I put the electrons as far apart as possible. So you're always going to put the electrons as far apart on the orbital as possible, because likes repel. Now when I'm talking about electron configuration, so write electron configuration, that is simply a shorthand way of saying where the electrons are. So this is shell 1, this is shell 2, and then it's a representation of how many electrons are in that shell. So the electron configuration in this one would be 2, because it has 2 shells, 2 dash, and then how many are in that last shell? Just 1. So my electron configuration is 2-1. We're only going to be looking at the outermost, or valence shell in this case, for the electron configuration. Now my Lewis dot structure, this is another way of representing this, but way, way shorter. Okay, when you're doing a Lewis dot structure, you don't have to worry about drawing the number of protons or neutrons, or even the shells. You're only going to look at the symbol and the number of electrons in your valence, or outermost shell. Notice that there's nothing in this one, so we pretend it doesn't exist. Well, I look up here and I see that my symbol is lithium, and you're going to surround the symbol by the number of valence, or outermost electrons. Well, on my outermost shell, I only have 1, so guess what? I'm going to put 1 here. Now, you could also do this, or this, or this. You're either going to put it on the left, the top, the right, or the bottom. That all means the same thing. So this, and this all mean the same thing. So for this example, our Lewis dot is only going to have 1 valence electron around it. But let's look at another example. So let's say that we are talking about sodium. Sodium. So let's find sodium, which on the periodic table is number 11. And let's look at the atomic mass on the periodic table. Well, it says that the atomic mass is 22.9 blah blah blah, which we round to 23, which is why this one says sodium 23. It's specifically telling us that there are that the atomic mass is 23. So now let's fill in. Our atomic number is 11. Where did I get that from? Right here. The atomic mass number, or the mass number, is going to be 23. It told us that the mass of this specific sodium is 23, but if you're not given the mass, you just look at the atomic mass on the bottom and you would round that to 23. So now again, we can look at ape man to figure out the number of protons, electrons, and neutrons. So the number of protons will always equal the number, or the atomic number, which is 11. The number of electrons is also 11. And our number of neutrons is always going to be our atomic mass minus the atomic number, which is going to give me 12. So let's take all this information and let's fill in our Bohr model. So our number of protons is going to be 11, which will be in the nucleus. Our number of neutrons, which goes in the nucleus again, will be 12. And then we're going to have to fill in our number of electrons. Now we have to go back to our rules. 2 and 8 is great. So The first one can hold up to 2. So I have 11 electrons to fill in. So I have 1, 2, and then I move up to the next one because that seat is full. 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8. This one's full now. You can't fit any more, so what are we going to have to do? We're going to have to bump up to the next seat. 11. So we have 2 in our first shell, a maximum of 8 in our second shell, and because we filled up our second shell, the next electron has to bump up to the next shell. So the electron configuration is going to be not orbital 1 or orbital 2, but orbital 3. And then how many electrons are actually in it? So it's 3-1. Now with our Lewis dot, remember this one's the easier one, the one that all you have to do is put the symbol up in the middle, and then you have to put the number of valence electrons around it. Well, the valence electrons, you only look at your outermost shell, and guess what? There's only 1 on sodium, so again, you just put a dot beside it. Could it be up top? Sure. Could it be on the side? Yeah. Could it be down there? But you only have 1. All right, let's look at our last example before we break out. So, chlorine. So you have to find chlorine on your periodic table, and Cl is your symbol. So if you look at on your periodic table, you'll see chlorine is atomic number 17, and your atomic mass on the periodic table is 35.4, but this one's telling you that this one is specifically an atomic mass of 37, so your atomic mass is going to be 37. So your atomic number, where do I get it? From the periodic table, is 17. What is the mass of that specific chlorine? We're going to say that it is 37 because it tells us right here. And then we have to figure out our number of protons. Again, protons is just your atomic number, just like electrons, 8. And then man. So if you're trying to figure out your neutrons, the N in man, it's going to be your mass minus your atomic number. So 37 minus 17 gives you a total of 20. So then we take all this information and we put it in here. So protons in the middle, 17. Electrons in the middle, or excuse me, electrons go on the outside. Neutrons in the middle, 20. And then the electrons are 17. So now we have to use the 2 and 8 is great rule again. So 2 for the first shell maximum, and once you fill up that first seat, it bumps out to the next. So 1, 2, now we've used up 2. Now how many can fit in the second one? 8. So 1, 2, 3, 4, 5, 6, 7, and 8. So now I have 8 and 2, which gives me a total of 10. But have I used them all? No, I need 17, but this seat is full. So where do I have to go? I have to bump up to the next one. So I have to put 1, 2, 3, 4, 5, 6, and 7. So now I have 17 electrons, 2 in the first one, 8 in the second one, and then I have 7 in the last one, making a total of 17. So what's my electron configuration? Well, it's not 1, it's not 2, it's 3, so 3 dash. Then I have to figure out how many are in this one. Well, there are 7, so 3-7. Now with my Lewis dot, you're going to take your symbol, which for chlorine is Cl, and you're going to surround it by the number of valence electrons, which again, valence electrons are ones on the outermost shell, so that's 7. So I fill up all the way around before I start doing it again. So you'll notice that I'll skip around 1, 2, 3, 4, 5, 6, and 7. You have a maximum of 2 on the top, 2 on the side, 2 on the side, and 2 on the side. Or 2 on the bottom and 2 on the side. So you're going to fill up all the way around. You're going to put 1 on each side first, and then you will double up. Because we have 7, you should have noticed that I put 1, 2, 3, 4, and then doubled up 5, 6, 7. Okay? So let's say, for instance, we had sulfur. Well, sulfur has 6 valence electrons, so you're going to have to put 6 around it, and you're going to do it the same way. 1, 2, 3, 4, and now I have to double up. 5 and 6. All right. I hope everyone enjoyed, and you have a great day. Enjoy the Bohr model.